The Multiverse Revealed, Episode 9.
The great debate, is the multiverse science or fantasy?
What counts as real in physics? A thing you can touch, or a pattern your best equations cannot stop predicting? If our most successful theories keep pointing past one universe, do we follow the math or fire the mapmaker? Tonight we stage the debate. Multiverse isn't one idea. It's a menu of proposals that pop out of otherwise serious physics. Inflationary cosmology can naturally spawn countless bubble regions, cosmic patches with different low-energy physics. String M theory suggests a landscape of allowed vacua. Different pockets can realize different constants and particle content. Everett Manyworlds reads quantum theory literally. The wave function doesn't collapse, it branches. Some even push to a level for 4, where entirely different mathematical structures define different realities. Max Tegmark gathers these into a 4-level hierarchy, II4, so we stop arguing past each other and ask the right questions about which levels of physics and how to test them. Carr's anthology frames the stakes. Multiverse talk moved from taboo to mainstream because of fine-tuning, the odd fact that life needs cosmic knobs set just so. If serious theories already imply ensembles, selection effects, anthropic reasoning, become tools, not taboos. The dispute is whether those tools can be sharpened into testable science.
Map the battlefield.
The levels, so we speak the same language. Level 1. Regions beyond our observable horizon within the same cosmic space. Same laws, different initial conditions. Inflation generically predicts an effectively infinite space with Hubble volumes realizing all initial conditions. Level 2. Other bubbles from eternal inflation or other mechanisms with different effective laws, constants, dimensionality, particle content. Level 3. Everett branches from unitary quantum mechanics. Decoherence gives separate classical histories. Crucially, Level 3 doesn't add qualitatively new universes beyond the variety already present in Levels 1-2, just more copies distributed across branches with the same statistics. Level 4. Universes based on other mathematical structures, the most speculative tier.
1. George Ellis, The Skeptic's Edge, describe, uniquely,
Ellis presses a sharp methodological point. To say there is a multiverse, you must 1. Specify a possibility space of universes, then 2. Specify a distribution, measure, over that space for which ones actually exist. We have neither in a unique derivable form. Without uniqueness, and without empirical access to the purported generative mechanism, claims risk drifting into metaphysics rather than physics. It can be explanatorily useful, Ellis grants, but don't confuse that with scientific testability.
2. Don Page, The Conditional Yes. Show me your measure, I'll show you your likelihood.
Page offers a practical route. Multiverse theories can be tested statistically if they come with a well-defined measure for observations. Then we can do Bayesian comparisons, using a theory's typicality. The probability that a randomly drawn observation would be at least as extreme as what we actually see, as a likelihood. The subjective priors remain an issue, but the method turns ensembles into quantitative predictions about our data. Page even sketches prior assignments that split credence between single universe and multi-universe meta-theories to keep the comparison fair.
3. Anthony Aguirre, The Playbook. Avoid the traps, define the game.
Aguirre accepts that many universes follow naturally, from eternal inflation and M-theory ideas. His focus is how to make predictions, enumerate what must be specified, observer class, cutoffs to regulate infinities, choice of measure, warn about conundrums, example Boltzmann brains and reference class ambiguity, and identify any generic qualitative signatures that many multiverse models would share. It's a strategy document, not a guarantee, but a path away from hand-waving.
The two technical dragons and how people tame them.
A. The measure problem counting in an infinite hall. If there are infinitely many of each kind of universe, naive ratios, how common are life-friendly ones, become ambiguous. Different regulators yield different answers. Page's solution is, bring the measure with the theory, no measure, no test. Aguirre's is, derive or justify the measure from dynamics and be explicit about cutoffs. Then test for robustness under reasonable variance. B. Typicality reference class, typical among whom? Are we typical among all observers, all human-like observers, all observer moments? Change the who, change the prediction. Page treats typicality as the likelihood function itself, clear but delicate, and stresses that priors and classes must be stated up front. Aguirre's warning, it's easy to get misled by a convenient but unjustified reference class.
A falsifiable template. Smolin's cosmological natural selection.
Smolin proposes universes reproduce through black holes. Parameters that maximize black hole production become more common in the ensemble. This approach makes risky predictions. Example, parameter tweaks that would lower black hole formation should be rare in our universe. Crucially, it's vulnerable to falsification, which Carr highlights as a model virtue. Regardless of your taste for the idea, it behaves like science.
Quantum branches. Why level 3 isn't a free pass?
Tegmark's analysis tightens a common worry. If you already accept unitarity, no information loss, and decoherence, then level 3 doesn't add new outcomes relative to what level 1-2 already provide. It repackages the same distribution across branches. The experimental case for unitarity keeps improving, from buckyballs to long fiber interferometers, and theoretical tools like ADS-CFT support unitarity in quantum gravity, which indirectly buttresses the Everett picture. That doesn't settle interpretational debates, but it undercuts the claim that many worlds that are pure fantasy.
What would count as evidence?
Predictions by typicality. If a model measure says observers should most often see constants near anthropic boundaries and we sit near such edges, that's a point scored for that particular model. Page's Bayesian recipe is the framework for making this precise. Common scaffolds, separate tests. If the mechanism that implies a multiverse, example inflation, makes other successful testable predictions, confidence in the whole scaffold, not just its visible flaws, goes up. This is Aguirre's strategic angle. Falsifiable ensemble models. Ideas like cosmological natural selection live or die by empirical blows, a healthy sign.
Criticism, counter-criticism, fast round.
Unobservable is unscientific. Ellis, without a unique possibility space and distribution, it's philosophy. Reply, Page, test the statistical consequences for our observations if the theory supplies a measure, otherwise no pass. Measures are arbitrary, typicality is voodoo. Reply, Aguirre, make the choices explicit, derive where possible and check for robustness. Don't sneak in conclusions with sloppy setups. Everett adds fantasy universes. Reply, Tegmark. Level 3 adds no new variety beyond I2. It repackages the same distribution over branches if physics is unitary. Anthropic arguments explain nothing. Reply. In an ensemble implied by your theory, selection effects become constraints, not excuses. They can be cast as likelihoods in Bayes.
Two relatable scenes.
The scholarship letter, Against crazy odds, you win the scholarship. Was it fate? No, the university printed thousands of tickets. Your win is still real. The printing press is part of the explanation. That's the anthropic move, not replacing meaning, but clarifying mechanism. The library at night. You're hunting one specific truth. There are many rooms, each with a catalogue. The multiverse debate is really about catalogue design. Do we accept the catalogue that finds more true shelves with fewer ad hoc notes?
Final thought.
Science isn't defined by what we can hold, but by what we can corner, with sharper definitions, cleaner measures, and predictions that risk being wrong. If the road to our best explanations passes through many worlds, the task is not to barricade the road, but to pave it, number the mileposts, and publish the map. Choose the map that finds real shores. Names are wind, prediction is compass. If this episode clarified the debate, help us keep making deep dive films about hidden knowledge. Like, share, and subscribe to Positive Vortex. And if you'd like to support the channel directly, tap thanks or join to walk further with us.